Okay, we are talking about single replacement reactions, and there's a couple special cases that I just want to talk about. A single replacement reaction with water and what happens with that, and then I covered a little bit on single replacement reactions with halogens, and I just want to retouch on that. Okay, so we're going to start with single replacement reactions with water. Okay, one of the things that we talked about earlier this year was that group 1 elements react with water. And I'll be more specific here and say group 1 metals react with water. When we were talking about the periodic table, we talked about the fact that group 1 elements are so reactive that they react with water. And they do that in a single replacement reaction. So if I have lithium metal, okay, and that reacts with water, okay, one of the things that happens is it's kind of different how these reactions form products. Okay, it's still a single replacement reaction. This lithium still replaces a hydrogen, but it doesn't replace both hydrogens. It only replaces one. Okay, so what's going to happen is this Li is going to form LiOH, and then I'm going to have a hydrogen that's left over, but because hydrogen is a diatomic element, okay, it has to be H2, and that hydrogen is actually going to be a gas, and this is going to be aqueous, and again, why that's aqueous we'll learn in the next particular chapter. Okay, but this is the single replacement reaction that actually happens with metals. Okay, what they do is they form hydroxides. Okay, they form hydroxides, and just remember a hydroxide is the OH polyatomic ion. Okay, so let's just look at another one quick. If I have sodium plus H2O. That sodium plus H2O, this is going to kick out one hydrogen. So one hydrogen is kicked out, but I'm still left with a hydrogen and an oxygen. And so that hydrogen and oxygen is negatively charged. And so I'm going to get NaOH plus a hydrogen. But again, that hydrogen is diatomic, so we need an H2 there. Okay? And I haven't balanced any of these, but of course we should always go back and balance. But I just wanted to show what was happening with single replacement reactions and water. Okay? So I'm going to give you one last one that I'd like you to complete. So I have potassium plus H2O. Complete that reaction. And you should get KOH plus H2. And on both of these, the H2 comes off as a gas. And I could show you this as a demo as well. So ask me to see the demo of this, and I will show you what that looks like. Okay? Now, the other thing, and I talked about this in the last video, but I just want to reiterate kind of single replacement reactions with halogens, okay, and kind of talk about these. Your activity series that you have has the bottom section on it that is all about just halogens, okay? And so if I have chlorine plus NaBr, okay, that chlorine, this chlorine right here, is not going to replace a group 1 element. That's not what's going to happen. Okay, that chlorine is going to replace the Br. Okay, so whenever you see a halogen as one of your reactants, and you have another reactant that has a halogen in it, that chlorine or that first halogen is going to replace the other halogen. So what I'm going to get for products is NaCl plus Br2. And that Br has to be a diatomic because it's one of our 7 diatomics. Then, of course, I'd have to go back and balance, and balancing these is actually fairly easy. Okay? So if I have F2 plus Ki, what would the products of that reaction be? And hopefully you are seeing that the F2 would go in and replace the K, or excuse me, replace the I, not the K. And so I get Kf plus, now the I2 is what's been kicked out. And the last one I want to give you is if I have I2 plus LiF, what would the products be of that? And hopefully you are saying no reaction, okay? Because iodine is below fluorine, and only elements above other elements can replace this. So this is a no reaction, okay? That's all I wanted to review with on these to make sure you understand what's going on with those.